Hi, my name is Karolina. I'm a virology PhD student, and because I believe virology is full of fascinating stories, I decided to share some of them. We all know the story. When Europeans set sail for the so-called New World, they didn't just bring ships and cargo. They also brought deadly diseases. They introduced pathogens into regions where no one had ever encountered them before. And in some areas, these outbreaks wiped out between 50 to 90% of local populations within just a few years. Most of us can name the usual suspects: smallpox or influenza. But fewer people realize that measles was nearly as deadly. In fact, historians often rank measles as the second deadliest of the imported epidemics. And in today's episode, we are diving into everything measles. You probably already know to be cautious when somebody calls measles a harmless childhood disease. But how dangerous measles really is, and how common are the serious complications? Spoiler alert, it's far from innocent. Alright, so what is measles? Let's start with what it looks like when nothing goes extra wrong. Just a typical case without complications. Measles usually begins innocently enough, like a bad cold or flu. In the first few days, you might have a high fever, cough, a runny nose, and red, watery eyes. At this point, it just feels like a miserable flu-like illness. But there's one classic clue that tells the doctors what's really going on. Tiny white spots that appear inside the mouth. These are called Koplik spots, and they are a telltale sign of measles, usually showing up a couple days into the illness. Then, around days 3 to 5, things start to escalate. A red blotchy rash breaks out on the face and quickly spreads downward, covering the entire body. The fever often spikes again, and the person may look and also feel seriously unwell. This is the textbook phase of measles: glassy eyes, red spots everywhere, and a child who looks very sick. The rash lasts about 5 days and then slowly fades away, and the patient begins to recover. All in all, an uncomplicated case of measles usually lasts about 2 to 3 weeks, from the first symptoms to feeling normal again. Now here's the part that most people underestimate. Measles is more than just a rash. In fact, about 1/3 of measles cases develop at least one complication. Some of these are relatively mild, but others can be life-threatening. Let's start with the more common but less serious complications. First, about 10% of children with measles develop severe diarrhea, which might sound minor, but in toddlers it can cause serious dehydration. Then another 10% get a painful ear infection. Most of these clear up, but in some cases they can lead to permanent hearing loss. Then comes pneumonia. When you hear about children with measles ending up in the hospital, the reason is usually pneumonia. And what that really means is, these kids are struggling to breathe. They've developed a lung infection, either directly from the measles virus or from a secondary bacterial infection that took advantage of their weakened immune system. This is a serious and dangerous complication, and it happens in about 1 in 20 children, so around 5%. It is also the leading cause of death in young children with measles. Now let's talk about the rare but very serious complications. About 1 in 1,000 measles cases leads to encephalitis, which is inflammation of the brain. This can cause seizures or even coma. Sadly, about 15% of children who develop encephalitis don't survive. And even among those who do, it can leave behind permanent brain damage. And then there's an even rarer but very severe condition, subacute sclerosing panencephalitis, which is a bit of a tongue twister. And you can think about it as measles going into stealth mode. The virus stays hidden in the brain, and everyone thinks the child is cured. But then, 7 to 10 years later, you begin to see symptoms of the viral infection progressively destroying brain tissue. It is extremely rare. It only happens roughly in 1 in 100,000 measles cases, but it is almost always fatal. Of course, not every case leads to these outcomes, but the risk is real. Several factors affect how likely someone is to develop complications. They are most common in children under 5 and in adults over 30. And measles is also dangerous during pregnancy because it can lead to miscarriages or premature birth. Major risk factors for a severe course of measles are malnutrition and physical or mental stress. That's one of the reasons why measles mortality varies so much around the world. In high-income countries, measles mortality is as low as 0.1%, which still means that 1 out of every 1,000 infected children may die. But in low-income countries, mortality can reach 5%. That's 5 out of every 100 children. So yes, the risk is dramatically different depending on where you live. And the key deciding factors are: first, nutrition. Malnourished children, especially those with vitamin A deficiency, are much more likely to develop severe measles. Second is stress. Both physical and psychological stress can weaken the immune system and make complications more likely. And finally, another thing which decides is access to healthcare. The availability of medical care, especially for treating complications like pneumonia, can make the difference between recovery and life-threatening outcome. In wealthier countries, the death of a child from measles makes front-page news, as we were reminded not so long ago. But globally, measles still kills over 100,000 people every year. There is only one small consolation. You can only get measles once. The infection gives you lifelong immunity. The thing that makes measles really notorious is its incredible ability to spread. If you are wondering just how contagious it is, let me take you back in time to the windswept islands between Norway and Iceland, the Faroe Islands, in 1846. Back then, the Faroe Islands were under Danish rule. Fewer than 8,000 people lived there, scattered across remote coastal villages. People rarely traveled, and visitors were even rarer. As a result, measles hadn't reached the islands for 65 years. Until one day, a local man returned from a trip to Copenhagen. He wasn't feeling well, but the doctor didn't recognize it as measles. While he was recovering at home, 2 neighbors helped care for him. And when he got better, they returned to their families. 2 weeks later, both neighbors fell ill. And when the classic rash appeared, it became clear. measles had finally arrived to the Faroes. Because the virus didn't circulate there for nearly 7 decades, almost everyone was susceptible, and the community had no natural immunity. Alarmed, the Faroese asked the Danish crown for help. And in response, 2 young medical graduates were sent to the islands. One of them was Peter Penham, the central figure in this story. Over the next few months, Penham crisscrossed the islands. He visited more than 50 villages, collected data, spoke with families, and he studied church records. Eventually, he wrote a detailed report that would make him a legend in epidemiology. Well, to be honest, the report actually starts with complaints about the food, about the gloomy weather, and how unpleasant he found the locals. But once he gets past that, comes the groundbreaking part. Penham noticed something very consistent. The time between exposure to measles and the appearance of symptoms wasn't random. It was almost always exactly 14 days. For example, in early June, 10 men from the remote village of Tjornjevik traveled to the town of Vestmanna to join a whale hunt. There were measles cases in Vestmanna, but none yet in Tjornjevik. The men joined the hunt, they received their share of the whale meat and returned home. And then, exactly 14 days later, all 10 of them developed measles on the same day. And 2 weeks after that, their families became sick as well. Another example. In one household, only one daughter fell ill, and her family assumed they were in the clear. But Penham predicted otherwise. He literally told them to mark their calendar, because in exactly 2 weeks, he said, they'd all be sick. And sure enough, 14 days later, every single one of them had measles. Noticing this pattern may not seem like a big deal, but Penham's observations were so remarkable because in cities, tracking patterns like this was nearly impossible. There were too many people with too many contacts and too many unknowns. But on the isolated Faroese Islands, the connections were clear and traceable, and that made all the difference. Eventually, the Faroe Islands outbreak ran its course. It lasted for about 6 months, and in that time, measles infected over 6,000 people, out of just some 7,700 people living on the islands. So that's more than 3/4 of the entire population, and about 170 people have died. And Penham noticed one more thing. No one who had measles during the previous outbreak in 1781 got sick again. This confirmed what we know today. Measles infection gives lifelong immunity. But back then, medical journals were still debating so-called repeat measles cases, but the Faroe Islands outbreak made it clear. Most of those were most likely just misdiagnoses. So what can the Faroese outbreak teach us? One of the main lessons is measles is, simply put, ridiculously contagious. It's so contagious that a single infected person can infect up to 90% of unvaccinated people they come into contact with. Its R0 number is between 12 and 18, which means that in a susceptible population, one person with measles can infect 12 to 18 others. But how exactly does measles spread? Measles is caused by a measles virus, which is an RNA virus that belongs to the Paramyxoviridae family, and it spreads through the air. When someone with measles coughs, sneezes, or even breathes. Also, the virus can remain contagious in the air or on surfaces for up to 2 hours after the infected person has already left the room. Since it spreads through the air, the measles virus enters the body through the nose or throat, just like many respiratory viruses. But measles doesn't just stay in the airways. The virus actually goes straight for your immune system. It infects dendritic cells and macrophages, and these infected cells then travel to the lymph nodes, of course, bringing the virus with them. Once in the lymph nodes, the measles virus rapidly multiplies inside lymphocytes, another key part of the immune system. From there, the virus spills into the bloodstream. This is a stage called viremia, and the virus begins to spread throughout the whole body. That's when you start to feel really sick. The immune system is now fighting the infection, and the rash you see is actually your immune system attacking infected cells in the skin. The virus can be transmitted from 4 days before the rash appears until about 4 days after. And the peak infectious period is usually right around the time the rash erupts. And that brings us to the next chapter, treatment. The bad news? It doesn't exist. There is no specific cure for measles, so treatment is mostly about managing symptoms while the body immune system fights off the virus. Since measles can range from relatively mild illness to something much more serious, the approach also depends on how sick the person is. Mild cases can usually be managed at home with supportive care, so things like rest and plenty of fluids to prevent dehydration. But severe cases, and those with complications, may require hospital care. I have already talked about the common cause of hospitalization with measles, pneumonia. Pneumonia can be caused directly by the measles virus, or it can come from a secondary bacterial infection that takes advantage of the weakened immune system. In such cases, patients are often given antibiotics, not to treat the virus, but to fight the bacterial pneumonia. And they may also receive extra oxygen if they are having trouble breathing. And then there's encephalitis, an inflammation of the brain, which, of course, requires urgent hospital care. Treatment may include anti-inflammatory drugs like corticosteroids to help reduce the swelling of the brain. But there is one more part of treatment we haven't talked about yet, and that's vitamin A. A deficiency in vitamin A is linked to worse outcomes. In fact, children with low vitamin A levels who get measles are much more likely to experience serious complications, including blindness or even death. Vitamin A therapy has been shown to reduce mortality and lower the risk of complications, especially in young children, which are hospitalized with measles in developing countries. That's why health organizations around the world, including the WHO, recommend giving high-dose vitamin A to all children diagnosed with measles. However, vitamin A is a great help in a case of malnutrition. But otherwise, it's not a magical treatment. In fact, we now have some evidence suggesting that in well-nourished children, like those in high-income countries, vitamin A doesn't make much difference in measles outcomes. That insight actually came from a study that happened more or less by accident. And to fully call them out, it was an accidental study done in Italy. The WHO recommends high-dose vitamin A for all hospitalized measles cases. These guidelines are based on strong evidence from developing countries, where vitamin A clearly reduces complications and saves lives. But until recently, there wasn't much data on how well it works in high-income countries, where malnutrition is rare. And of course, you can't ethically run a study where you deliberately withhold a recommended treatment from sick children. It would be completely unethical to skip giving kids vitamin A just to see what happens. But then, a measles outbreak hit Italy at the same time as a nationwide vitamin A shortage. And as a result, only a minority of hospitalized children were able to receive the recommended treatment. And because vitamin A was given based purely on availability, not clinical need, doctors ended up with something very close to a randomly assigned control group. In this unintentional study, 108 children hospitalized with measles were observed. And of them, 36 received vitamin A, while 72 did not. Doctors then compared both of the groups, and they were looking at how long the children had a fever, how many days they stayed in the hospital, and whether they developed complications or needed antibiotics. And the results? There were no significant differences in clinical outcomes between the two groups. So vitamin A didn't reduce symptoms, hospital stay, or complications in this well-nourished population. The likely reason why vitamin A makes such a big difference only in low-income countries is that it helps overcome immune weakness caused by malnutrition, especially by the vitamin A deficiency, which is still very common in many parts of the world. So, if you live in a high-income country and somebody suggests that measles can be managed with cod liver oil, perhaps such claim isn't exactly backed by solid evidence. So there is no specific treatment for the measles virus. But fortunately, we have another weapon, the vaccine. To tell this story, we need to go back to the 1950s, when a team of researchers set out to develop the very first measles vaccine. The central figure in the story is John Anders, a virologist whose earlier work helped to make the polio vaccine possible. That's because he developed methods to grow the polio virus in cell culture, which actually earned him a Nobel Prize. Now, he turned his attention to measles. But it was a tough challenge. There was no convenient animal model. He tried infecting mice, rabbits, and other lab animals, but nothing worked. So his lab focused on the next big step, isolating the measles virus and finding a way to grow it in cells. In the 1950s, Anders passed this challenge on to a research fellow named Thomas Peebles. Peebles had one job: to isolate the measles virus and to get it grow in the lab. Easier said than done. To grow the virus in the lab, you first need a sample from someone who's actively sick. Luckily, a colleague told Peebles about the measles outbreak at a local boys' boarding school. He got permission from the school principal to identify students in the early stages of illness and to try persuading them to take part in the study. So Peebles went to the boys and appealed to their sense of pride. I mean, do you want to help the world? And some of them said yes. He collected blood, throat washings, even some stool samples, anything that might contain the virus. So Peebles rushed back to the lab and began inoculating different types of cells with the samples, hoping the virus would grow. And on February 10, 1954, he introduced one sample into test tubes lined with a variety of human and animal cells. It turned out kidney cells were the key, because 5 days later, something unusual appeared. Giant multinucleated cells, a classical hallmark of measles infection. The team kept growing the virus and confirmed that it reacted with blood from people who previously had measles. That confirmed that they were on the right track. They had successfully isolated and grown the measles virus. The strain was named Edmonston, after the schoolboy who provided the sample. But isolating the virus was only the beginning. The next challenge? They had to weaken it. Just enough so that it could still trigger immune response, but no longer cause disease. In other words, they had to turn it into a vaccine. At the time, different labs and companies were exploring two main approaches. One was to kill the virus using chemicals like formaldehyde. This type of vaccine had only very few side effects, but it also triggered only a weak and short-lived immune response. Children needed multiple doses, and even then their protection often faded over time. The other method, explored by Andre's team, involved growing the virus in the lab for a very long time, giving it time to accumulate mutations and gradually lose its ability to cause disease. This process is known as attenuation. It works by repeatedly passaging the virus through different types of cells and species. In this case, they first grew the virus in human kidney cells, but then in human amnion cells, followed by chicken embryos, and finally chicken cells. As the virus adapted to these new environments, it became better at infecting chicken cells, but worse at infecting humans. Eventually, the team ended up with a version of the virus that could still trigger a strong immune response, but no longer caused a full-blown disease. The first real test of the weakened, attenuated virus came in monkeys. Monkeys don't usually get measles, but they can be infected under laboratory conditions. And when they were vaccinated with the attenuated virus, they developed no fever, no rash, no signs of illness. But they did produce strong anti-measles antibodies. And when they were later exposed to the real, full-strength virus, they were fully protected. It was time to take the next step, testing the vaccine in humans. The first versions were far from perfect, because they caused nasty side effects like fever and rash. So the researchers had to go back to the bench, and the virus had to be further weakened in the lab. The vaccine we use today is a direct descendant of the original Edmonston strain. It was just further attenuated and weakened and made safer over time. And in 1971, Maurice Hilleman famously took things one step further. He combined the measles vaccine with vaccines for mumps and rubella, creating the MMR vaccine. So with a single shot, you can now get protection against all three diseases. To give you some numbers on the impact of vaccination, it is estimated that in the past 20 years, measles vaccination has prevented more than 60 million deaths. But, and this is important, despite having a safe and effective vaccine, measles still kills over 100,000 people every year. Mostly unvaccinated children in areas with limited access to healthcare and vaccines. Measles remain common in parts of Africa and Asia, where consistent vaccination programs are still difficult to implement. And because measles spread so easily, we need very high vaccination coverage to stop it. About 95% of population needs to be vaccinated to achieve herd immunity. In high-income countries, the situation is generally better, and outbreaks tend to be limited to unvaccinated communities. But even in these countries, measles can still be a threat, especially to people who can't be vaccinated, like babies who are too young. And there may actually be more than one way the measles vaccine saves lives. There is another consequence of the measles infection that I haven't mentioned yet, mainly because it's a relatively recent discovery and we still don't fully understand it. Earlier, I mentioned that measles infection is associated with immunosuppression. The virus targets immune cells and causes acute weakening of the immune system, leaving patients more vulnerable to secondary infections. But some research suggests it's even worse than that. It points to a phenomenon called immune amnesia, where measles doesn't just temporarily weaken the immune system. It actually wipes out existing immune memory, hence the name amnesia. In other words, after measles, your immune system might forget how to fight infections it used to recognize. One study looked at blood samples from 77 unvaccinated Dutch children taken both before and after measles outbreak. And what they found was striking. Measles infection erased between 11 and 73% of their existing antibodies. Not just antibodies against measles, but also those targeting other bacteria and viruses the children had previously encountered. In contrast, children who had been vaccinated against measles showed no such loss in their antibody levels after vaccination. On average, the samples were taken 2 months after infection. But the researchers suggest that the effect may last much longer, possibly even years, because of the loss of plasma cells responsible for producing long-lasting antibodies. To confirm this, the researchers also experimentally infected monkeys with measles, and the result was the same thing: a significant loss of pre-existing antibodies, which lasted at least 5 months. Researchers have connected these findings to something epidemiologists have observed for a long time: a rise in illness and death for years after measles infection, even from diseases unrelated to measles itself. And the reason behind this pattern remained poorly understood. But now it could be possibly explained by the immune amnesia. For example, one study analyzed health data from Brazil to examine how measles affected childhood deaths from other infectious diseases. And they found a clear pattern. Children who had measles were more likely to die from other infections in the months that followed. This effect lasted for about a year, suggesting a long-term weakening of the immune system after the infection. As a control, the researchers also looked at deaths from circulatory diseases like heart problems, so illnesses which shouldn't be affected by measles or its aftermath. And as expected, they found no link between measles and those deaths. So the connection was specific to infectious diseases. But when it comes to immune amnesia, not everyone is convinced. There are some studies that didn't find clear signs of immunosuppression after measles infection. So in these studies, researchers didn't observe long-term effects on the immune system. I read an article from scientists who questioned the idea of immune amnesia. However, even they didn't dispute one key observation, that measles vaccination seems to reduce deaths from other infections as well. And they believe that this may be due to some non-specific immune boost, a kind of bonus effect from the vaccine that we don't fully understand yet. But I think that right now there are no solid proofs for this hypothesis. And as for my own opinion, I do think that there is solid evidence that measles causes immune suppression. But we still need more research to understand how long it really lasts. Because you may hear claims that the immune amnesia effects can persist for years, but I think that based on the data we have right now, the evidence points more to effect that lasts some months, not some years. So I think this is what the data says, at least for now. And before we wrap up this episode, I have to mention the infamous MMR vaccine scandal. As I said earlier, the measles vaccine was eventually integrated into the MMR vaccine, which protects against measles, mumps, and rubella. This is the vaccine that was falsely linked to autism in a now debunked and fraudulent research study. I have actually a whole episode dedicated to the story. It's episode 3. So here I'll just give you a quick rundown of the key facts. It all began with Dr. Andrew Wakefield, who launches so-called research into vaccines and autism after striking a deal with a lawyer who was preparing a lawsuit against vaccine manufacturers. Wakefield was personally paid by the lawyer, and his study was financially backed by a legal organization. In his 1998 paper, he described 12 children who allegedly developed autism shortly after receiving the MMR vaccine. But it later came to light that the data had been manipulated, and none of the cases were described as they actually happened. For example, the paper claimed that one child developed symptoms 1 week after vaccination, but official medical records show that the symptoms started a month before the child ever received the vaccine. Another case reported symptoms 2 weeks after vaccination, but in reality they began 6 months later. The paper also claimed that all children were previously healthy, but in fact 5 of them had documented developmental issues before they were ever vaccinated. And to make things worse, during their hospital stay, the children underwent painful and unnecessary procedures that provided no benefit to them. It was all in the name of supporting the study. The paper was eventually fully retracted by the journal. And fun fact, if you can call it that, Wakefield had already filed a patent for his own, supposedly safer measles vaccine before publishing his paper. Since then, many independent research teams have studied the question, whether there is any link between the MMR vaccine and autism. And the answer was no. Large, high-quality studies found no associations. The MMR vaccine did not increase the risk in autism, and not even in children with some genetic predispositions. And as our understanding of early brain development improves, we now know that the changes which are seen in autism begin before the MMR vaccine is even administered. So again, if you are interested in more on this topic, it's all discussed in episode 3 of the podcast. Okay, one day I will end an episode on a positive note, but today is not that day. Today we are ending on the hoax. So here's one very final summary. Measles is commonly complicated, it's highly contagious, there is no cure, but there is a vaccine. And with that, thank you so much for listening. And also thank you for all the support I've been getting. People are really nice to me about this and also sharing the podcast and everything, and I really appreciate it. As always, I'll list all the sources for the episode in the description. And now I get to do my favorite part, just read and read and read to prepare for the next episode. And again, thank you.